The second review is focusing on dimensional analysis. Here you see an example of a dimensional analysis problem in terms of going from yards to centimeters. I do not expect you to know English conversions such as yards to feet or even feet to inches or inches to centimeters, but there are some metric conversions you will need to know. Just a review of the steps you would need to follow in terms of solving a dimensional analysis problem. You always want to identify what's given to you in the problem and set up a conversion factor that's going to help you get rid of what you're starting with and hopefully help you get towards what you're trying to find. You may need more than one conversion factor, which is why you see a step 3. Step 4, you want to multiply your values across and then divide by any values in the denominator. Remember to combine all the numbers in the denominator before you do your division, and then you want to apply your sig figs and rounding rules. Remember that defined values do not have sig figs, so all of the conversions listed here are not ones that would have any effect on the significant figures in your answers. These are the same conversions. On this side here, we're going from largest to smallest. So you have the megagrams, you have it in terms of an ordinary number, and you have it in terms of an exponent. And you don't really see these change a whole lot until you get down here with deci, because since you fall below the placeholder, we can set this up in terms of the base unit, having however many of the smaller unit are inside of it, or we can set it up in terms of the prefix. So it depends on whether you prefer working with really big numbers or really small numbers. My preferences are these, but that's totally up to you. You do need to know these prefixes. You have a mnemonic down here at the bottom that may help you with this. Many kids have dropped over dead converting metric measurements in problems. If you notice with these prefixes, we start up here with 6, we drop down to 3, so we've gone from the millions to the thousands, and then we go down by ones, 2, 1, 0, and then with over here, again we're talking about these in terms of the larger quantity, -1, -2, -3, and then we start going back up again by 3s, the -6, -9, and -12. There is a shortcut I can show you to go between prefixes using these exponents. I'm going to save that for in class. If you would like to see it sooner, please feel free to stop by and see me, and I will help you out with that. So our first example is going from milligrams to grams. So we start with our milligrams, put them over 1, and we want to cancel out the milligrams. We want to find the grams. And if we go back to our previous slide, we will see that 1 gram is the equivalent of 1,000 milligrams. So the milligrams are going to cancel. We would multiply the 3,800 and the 1 together, divide by the 1 and 1,000. This does not affect my significant figures, neither does the 1. So we're only dealing with the 3,800 having sig figs, and that number has 2. So when we do the math through, we would get 3.8 grams. In our second example, we want to know what the microliter equivalent would be to 0.00475 deciliters. This is one because we have 2 prefixes, the deci and the micro, we would need at least 2 conversions to do this. So we start with what we're given, the 0.00475 deciliters, and we're going to use the liters, the unit without a prefix, as a placeholder. So deci would go on the bottom and liters would go up top. And if we go and take a look at our conversion chart, we'll see that deci is 10 compared to one of the base units, so 1 liter has 10 deciliters. So the deciliters are going to cancel out, leaving us with liters at this point, but we want to get to microliters. So we're going to do one last conversion going from liters to microliters, and we see here that micro is 10 to the -6, which means it's 1/1,000,000th the size of a liter. So 1 million microliters will fit into 1 liter. The liters cancel. When we multiply across and we divide, we get that this number here had 3 sig figs because those leading zeros don't count. These two are defined quantities, so they don't have sig figs. So we want 3 sig figs in our answer, 475 microliters. You could also write that in scientific notation as 4.75 times 10 to the second. Now I'm going to stop this for a brief second before I move on to the third example and go back to this real quick. Hopefully you've seen we dealt with both grams and liters in those first 2 examples. all of these conversions have grams in them, but at the bottom I told you you can substitute any unit for the grams. So here it says 1 gram is 1,000 milligrams, 1 liter is 1,000 milliliters, 1 meter is 1,000 millimeters, 1 second is 1,000 milliseconds. You've got plenty of choices to go with. You can use any unit in place of those grams, so don't get too worked up over the fact that grams was used specifically in this conversion table. I would encourage you to make flashcards if you're having trouble keeping straight what unit's being represented by what symbol. And you don't have to know all of these conversions, but you should know at least one. What does one of that unit represent in terms of the base, the one without a prefix, or what does one of the base represent in terms of that many of the prefix. Alright, so we have one last example to do in this step, and we're going to move down to example 3. Oh, I thought I had another one. Maybe I didn't. I thought I did a third one. I'm sorry. So you've seen all the 2 examples here. There are some time ones, I believe, on your homework, and those are straightforward. 60 seconds is in a minute, 60 minutes is in an hour, 24 hours is in a day, 365 days is in a year. And again, any of the English ones, inches to centimeters, ounces to pounds, things like that, those would be provided for you. So if we go back out to the summer assignment, you now should be able to do questions 5 through 11. Think about how many nickels are in a dollar, and if that one's causing some trouble. You could do nickels and a dime, how many dimes are in a dollar, nickels and a quarter, how many quarters in a dollar. It really doesn't matter how you do it, as long as you are using appropriate conversions. And I will tell you for number 8, they didn't really give significant figures on this one. 90 without the decimal would have just 1 sig fig. So if that's all you report your answer to, that's fine.